Hello, my dear students of BSc second semester. So today's our topic is reflected and transmitted energy coefficients. So in the previous lectures we have studied about the reflection and transmission coefficients of amplitude. Now in this lecture we will study the reflection and transmission coefficients of energy. In the last lecture we have done the derivation of I. What is I? The rate of flow of energy, or you can also say that intensity of a wave, and that is equal to half z a square omega square, where z is rho c, that is the impedance, and a is the amplitude and omega is the angular frequency. So from this we can say that intensity of a wave, or you can say rate of flow of energy, doesn't depend upon the position of the segment. Segment means that is the segment we take the small portion of the string. So it doesn't depend upon that. It depends upon z, a and omega, and amplitude z, the value of z for a given string will be same. So we can say that the rate of flow of energy will be same everywhere for a given string at all the times. So this is about the rate of flow of energy. Now our topic is to find out the reflection and transmission coefficients of energy. So for that we take two strings, they are joined together. So for that we take two strings which are joined together. This is the boundary, say x is equal to 0, where they are joined together. So one string is this and another string is this. So there are two strings. So this is means there are two mediums. One medium is this and second medium is this. For this impedance is Z1, for this impedance is Z2. And C1 for this is C1, wave velocity for this is C2, and wave is propagating through a string. So when a wave is propagating in a string, so wave incident in the first medium, then comes back, means reflection. So reflection and incident will be in the first medium, and transmission, this is a transmitted wave, this is incident wave, and this is, you can say, reflected wave. So incident and transmission, incident and reflection will be in the first medium and transmission in the second medium. And for this medium the impedance, that is Z1, for this impedance is Z2. So on the behalf of these values we can find out the values of I. So I means rate of flow of energy for incident wave, or intensity of a incident wave, that will be equal to half Z1. Now here Z1, A for incident amplitude is AI and omega square. The frequency will be same. Then for reflection, the intensity of reflected wave, or you can say that rate of flow of energy for reflected wave, that is equal to half. Now reflection is also in the first medium. For first medium impedance is Z1. So half Z1. So please take care of this. Z1. AR. We take the amplitude for incident wave. This is amplitude for incident wave. And for reflection we take AR for reflective wave, and for transmission we take AT for transmitted wave. Clear ji? So AR, this is here is the difference, and omega square. Then again IT for transmission, that will be half Z2. Now transmission is in second medium, so we take Z2 AT omega square, and amplitude we take for transmission 8. Now we have II, IR, IT. What is II? I am repeating again. This is the rate of flow of energy for incident wave, or intensity of incident wave, reflected wave and this is for transmission wave, a transmitted wave. Clear? Now using these we first find reflection coefficient of energy. So reflection, you can say reflection coefficient of energy. So the symbolical representation for this is RU for energy. Here, and this is defined as the ratio of the intensity of the reflected wave to the incident wave. So it is defined as the ratio of IR by II. Here, so when we take the ratios of these two, what you get? Oh, sorry, this is amplitude square here because A is square. So we have half goes with half, Z1 goes with Z1, omega goes with omega. So we have half Z1 AR square omega square divided by half Z1 AI square omega square. So omega square goes with omega square, Z1 goes with Z1, half goes with Z1. We have AR upon AI whole square. So I think you will remember this, that AR over AI. तो याद होएगा कि AR upon AI. What is AR upon AI? The ratio of amplitude of reflected wave to the incident wave. That is the reflection coefficient for amplitude. That is the reflection coefficient for amplitude. We have done this in the previous lectures. So AR upon AI, and the symbolical representation for this we take RA. Clear? So RA here. So what is RU is equal to, this is the reflection coefficient for energy. This is the square of reflection coefficient for amplitude. And the value for this is Z1 minus Z2 upon Z1 plus Z2. So and it's square. So this is R. Now in the second case we have to find out the transmission coefficient of energy. The transmission coefficient of energy. I write here transmission coefficient of energy. Coefficient of energy, and it will be the ratio of, how we can define it, and it is represented by TU. T for transmission, U for energy, and it is defined as the ratio of the intensity of the transmitted wave to the intensity of the incident wave. Or you can say this is the ratio of IT upon II. Clear? So this is the ratio of IT upon II. IT we have half Z2 AT square omega square. So it is half omega square Z2 AT square omega square divided by half Z1 AI square omega square. So I have taken the values from these. So now I rub it. So this is equal to, yes, this is equal to half goes with half, omega goes with omega. So this is, you can say TU is equal to AT upon AI whole square into Z2 upon Z1. And what is AT upon AI? What is AT upon AI? That is the ratio of the amplitude of transmitted wave to the amplitude of incident wave. This is the transmission coefficient for amplitude, and it is represented by TA. TA is pure Z2 upon Z1. And what's value of TA? The value of TA, that is equal to 2Z1. 2Z1 over Z1 minus Z2 whole square, Z2 transmission coefficient of energy is equal to sum of the values of Ru and Tu, means the ratio, the value of Ru and Tu. When we add them, what's the value is equal to question mark. So for this we add, taking this equation as equation number A and taking this as B. So Ru plus Tu, that is equal to, Ru is Z1 minus Z2 upon Z1 plus Z2 whole square plus I rub it now, a value of Ru plus the value of Tu. The value of Tu is plus 4 Z1 Z2 divided by Z1 minus Z2 whole square, A plus B. So now I rub it. Yes. Now we have to add these two for this. Yes. This is Z1 plus Z2 square. Yes, this is also Z1 plus Z2 square. I think Z1 plus Z2 square. This will be also equal to Z1 plus Z2. So I rub that portion. What we have write Z1 plus, because we know that the value of 2Z1 upon Z1 plus Z2. This will be the value of TA. The value of TA will be 2Z1 over Z1 plus Z2 plus, here will be, if we have brought in the previous minus, you have to put here plus. So बेटा जब minus पर चांस पाया गया तो तुसी इन्हू plus पा लेना, ठीक है? So taking LCM, Z1 plus Z2 square. So this is Z1 square plus Z2 square minus 2Z1 Z2 plus 4Z1 Z2, and this will be equal to plus 2Z1 Z2, and that will be Z1 plus Z2 whole square divided by also Z1 plus Z2 whole square. So this is equal to Ru plus Tu and equal to 1. So the sum of the reflection coefficient of energy and transmission coefficient of energy is equal to unity. Also law of conservation follows the law of conservation of energy. So I am repeating again that in case of Tu, we have half Z2 AT square omega square and half Z1 AI square omega square. Okay, so omega square goes with omega and we have half goes with half. We have AT upon AI square into Z2 over Z1, and AT upon AI, that will be Z1 2Z1 over Z1 plus Z2. So I am repeating again, here will be a plus sign. So square into Z2 over Z1. So from this will be equal to 4Z1 Z2 upon Z1 plus Z2 whole square. So this is a transmission coefficient for amplitude. Here there will be a plus sign. So that's why I am writing here plus. Clear? So this is plus. So from this you can say that the value of addition of Ru and Tu is unity. So thank you very much. This is a very important topic for examination point of view. From examination point of view.